This is where treatment changes completely. The plant begins relying on microscopic life.
It is only where you stop seeing it, and a massive system takes over. You press the flush button, and within seconds, everything disappears from sight. But it hasn't vanished, and that's when a massive underground journey begins.
From your home, that water enters a network most of us never see.
Before leaving the system, it passes through separation, biological treatment, disinfection, and quality control. So what actually happens between that familiar flush and the final outlet?
For a home on a municipal sewer, the water first enters its own drain system. Soon after, it enters the sanitary sewer and mixed with wastewater from other sources.
From here, it becomes part of a much larger urban wastewater flow. In many areas, gravity quietly carries it through buried pipes toward lower elevations.
Where gravity can't do the job, pump stations may lift the flow onward.
Near the treatment plant, the job changes from moving water to separating what's inside.
Large objects come first because they can clog or damage downstream equipment.
So screens usually remove larger debris before the water moves deeper into treatment.
But that's only the first defense. Sand, grit, smaller solids, and organics still remain. Now the system must move beyond blocking debris to more precise separation.
The next step uses something simple but powerful: gravity.
At many plants, primary settling slows the flow, letting heavy solids sink while oils and floating material rise.
The water may look cleaner now, but the hardest part is still inside.
Many organics are too small or dissolved to remove with screens or settling alone. This is where treatment changes completely. The plant begins relying on microscopic life. In many systems, large microbial communities break down biodegradable organic matter still in the water.
Air is often added to supply oxygen and keep that biological process working. As microbes consume organics, some of that material becomes biomass that can be separated. In effect, the system turns hard-to-remove material into something easier to collect. But that creates a new problem. How do you separate the microbes themselves?
In conventional activated sludge systems, the flow enters a settling tank where biomass can sink. The clearer water continues onward, while the biological solids collect at the bottom.
Some of that biomass can be returned to keep the activated sludge process going. Excess solids leave for separate treatment, and the water has now crossed both mechanical and biological stages.
Even then, looking cleaner does not mean the water is ready to leave.
After biological treatment, the question is whether the water meets the requirements for what comes next. A clearer appearance alone cannot tell you everything still present in the water. So many plants disinfect the water to reduce or inactivate disease-causing microorganisms. Depending on the facility, that may involve chlorine, ultraviolet light, or another suitable method.
Some systems need advanced treatment to further reduce nutrients or other pollutants, subject to discharge limits.
That's why no single treatment sequence fits every U.S. wastewater plant.
movements. But another point is easy to miss. Operators do far more than start machines.
Throughout the process, they track flow, treatment conditions, and indicators of each stage's performance.
Samples and operating data help reveal when part of the system begins drifting off target. That information lets operators adjust the process before one change affects later stages.
So treatment depends on three things working together: equipment, biology, and decisions guided by data. That coordination lets the system handle incoming wastewater that is never exactly the same. Scale up from one flush to the nation, and the job becomes enormous. EPA's 2022 count: 17,544 public plants serve 270.4 million people. But scale raises a harder question. What happens when incoming flow suddenly surges?
During wet weather, rainwater or groundwater can enter sanitary sewers through leaks or improper connections.
Across a wide area, that can push plant flows well above dry weather levels. The problem is, the plant cannot simply speed up every treatment stage equally.
Biological processes, especially, need enough time and suitable conditions to work effectively.
Peak flow becomes a balancing act. Handle more water while protecting treatment performance and effluent quality. As the water moves toward discharge, everything removed from it must go somewhere too. Screened debris and grit are handled separately, while settled solids enter the solids processing stream. Depending on the plant, sludge may be thickened, stabilized, or dewatered before further management. That is almost another system entirely, but following it would leave our main water journey. So let's return to the water that passed through physical, biological, and quality control stages.
By now, it is very different from raw wastewater, but it is not automatically drinking water.
For regulated surface water discharge, the plant must meet applicable permit limits and conditions.
Protecting the receiving water can require stricter effluent limits than minimum technology-based requirements. So a facility may need to further reduce certain pollutants before discharge is allowed.
And even after meeting those requirements, treated water has no single destination. In many systems, treated water returns to the environment through a managed discharge point. Where reuse programs exist, treated wastewater may need additional treatment before an approved reuse.
So the final path depends on the system, its permit, and local water management. The shared logic is simple. Each stage handles what the previous stage could not. Screens cannot do a microbe's job, and biology cannot replace effluent quality control.
That one stream of water therefore passes through several very different treatment jobs.
And now we can return to where the journey began: an ordinary household toilet. When you flush, the part you can see lasts only a few seconds.
Once the water disappears, it has been handed to a far larger operating network.
Gravity moves it, machines separate solids, microbes treat organics, and operators use data to stay in control.
When flow changes, those layers must still work together. They cannot all simply run faster.
So the flush is not where the water's story ends. It is only where you stop seeing it, and a massive system takes over. Thanks for joining Industry Unseen to follow the hidden journey behind an everyday action. If you enjoy systems like this, please like, subscribe, and keep exploring with Industry Unseen.